Our last but not least presenter, Dr. Joel Sherrill, one of our sponsors, our RTEMS State of the Solar System.
So, well, I guess I'm between everybody and lunch or flying home, so hopefully this is not going to be that bad. So I've been doing an annual kind of what the state of RTEMS and as a project and what things are coming up. Things if you weren't really actively tracking, you'd miss. So interestingly, I didn't realize how stressed I was last week getting this presentation together. And a couple of things, the Google Summer of Code students were announced Wednesday at about noon Central, but we also turned on GitLab.rtems.org at 11 o'clock Central. So we've had a lot of activity going on the project side. So I'm just going to tell you what's been going on with the network stacks, recent activities, project flow improvements, and then a little bit about Deos RTEMS, but hopefully Laurent talked mostly about it. So last year's GSoC students, we had somebody who attempted to add a lot of stuff to the Raspberry Pi 4B, and he got a lot of this stuff, and some of this is still pending review and merge. Alan Cudmore worked with a student to get support for a few BSPs for the readnode.io simulator, and simulators are real important to the RTEMS project because there is an enormous number of boards that RTEMS supports, and they're much easier to automate testing, and I mean, no one wants to own every board that's in RTEMS anyway. And again, there was more work, another project which added other peripherals for the Raspberry Pi 4. So this year, we got all 6 students projects that we thought were worth sponsoring. If you would like to help out and guide a student, you don't have to, it's not a huge investment time. But again, we're going to try to finish out the Raspberry Pi 4, and a lot of that stuff should go to the 5 because the peripherals should be similar. Believe it or not, we still do not have a completely 64-bit x86 piece BSP because, believe it or not, most RTEMS users don't use embedded PCs. They use like the Sparks or the Zincs or other processors that are even more obscure. GDB has a Python pretty printing subsystem, and this is there is some work on this, so hopefully this is just to turn it on, and then you'll be able to pretty print data structures from RTEMS. From a FACE technical standard and POSIX perspective, we are missing one method for what FACE calls the general purpose profile, and this project will be adding that one missing method. And if you've used RTEMS before, there's a good chance you've had the stack checker turned on, and you got this standard message maybe that said, I've blown the stack, your stack pointer's here, and the address range is here, and here's the thread ID. And this code has been in well over 25 years, and no one has ever suggested actually putting in a custom handler to report the fault. So I really don't know why, but this is so that can be a configuration point. I would have thought some project would have wanted something custom to log it. And the last one is there's a Beagle RISC-V version, and that we're going to get a BSP for that. So basically, if you look at it, it's improvements of things that might be used as a hobbyist or at home playing around. Some of them are fieldable. But over the past year and a half, and there's been some nice things done. NAND support for JFFS2. There's been a flash driver framework. There's been a lot of work on improving the performance of JFFS2. The NAND and NOR on the Zinc MP, and the system timer on the Raspberry Pi 4 has come along. My student last year or year before last, we went through and added all of the long double math routines for the processors that have them. And if you've ever gone down the rat hole of long double support, you know that most processors do not actually support it, and only some do. And then within some processor families, only certain models support it. So, but now we have long double, which where it's available, which is mostly on the primary architectures that people use. I didn't get an update from Jan Sommer, but there was ESA funding to improve RTEMS Rust support, and he's spoken here before in the past, but there's 2 or 3 people working on that, and that's coming along. And Ada Core is also, that's one of the things they now support. And we are very close to having CLang Tidy actually be able to support the RTEMS coding style. There's like 2 more changes that need to be merged into CLang Tidy. And then that will be something we'll start enforcing once the tooling is there. So over the past, say, 15 months, there have been some new BSPs. There were a bunch of A53 Zinc MP variants. There's now a new one that is just so you can do something very generic with simulators. There is now an R5 BSP, which can be run in conjunction with the A53s, particularly on the Zinc MP. We used to discourage adding simple variants to BSPs, but it makes it harder for people. So now there are a significant number of Zinc board variants where it turns out basically it changes the clock rate and the size of RAM, but now the board name is actually configured, and there are some others that are coming along. So this is a change that we've been working for a long time, is to make sure there's no network stack in RTEMS proper, and that when you configure your system, you actually can, it turned it into an add-on. So the first one a lot of you probably use is from FreeBSD. It is a very full-featured, and it's the first thing we'd normally recommend. It has lots of features, even packet filtering, IPv6. We get the USB stack. We get NVMe drives, NFS out of that, but it's too small it's too large for a lot of smaller targets. So we have also, at the same time, you've got an option. You can build LWIP. This is LWIP, again, it's an open source small stack. And we've got one of the problems with the project is the drivers are just all over the net, and there's no central repository for them. So the ones we know work with RTEMS are actually in the RTEMS repository. The old network stack was moved out into its own repository, and it is still an option. It is possible that if you're using old hardware that you just might want to keep using that. Hopefully people will not use it as much. LibBSD has got a lot of features. We use a lot of it. We have a clever technique of how we ported the software to RTEMS. There was a paper you can download from the FreeBSD journal from a few years ago, but where we try to keep up with the idea that you should be able to trace all of the source back to the FreeBSD and update easily. One of the things inside OER we've done is we have dedicated a pretty large server to automated testing, and it's got like 7 or 8 VMs on it, and at least once a week it will check if anything needs to be tested on 5, 6, and 7. 7 is like the next generation bleeding edge tools. And it's tested on a bunch of host operating systems that people use. The Mac OS, Jeff has got it working, but it's somehow not automated. This is where on the build results email list, a lot of the reports come from. And so if the tools need to be updated, it will build those. If RTEMS updated, it will then build all the BSPs. It can take up to 24 hours to do a full sweep of everything, even on a fast machine. So this is something that helps it make sure that we keep up with knowing things break. So usually I do this at the end, but these are things almost anybody can help with. Some of these are very small. We would like more code examples in the documentation. These are amazingly difficult to come up with. So if you've got a good idea and can come up with a snippet of code that looks handy for something, please submit it. BSPs for common dev boards and like the Beagles, the Pis, the STMs. We got a lot of STM BSPs now. Improvements to the Wi-Fi support. Mainly this is on the, if you want to play with that, more drivers and the way you attach to pick a network, an access point. Flash file system and unified flash device support are on one of these. JFFS2, we've learned, has some limitations that it might be nice to have a different flash file system for some deployments. Parallelization under SCL4. C11 has something called bounds checking functions. They are end with an underbar S. They're supposed to be safer. We'd like to have support for those, although I don't honestly know that anybody's using them. As we grow our CI, we would like some help setting up things, various code static analysis, the MCDC checker, and also we would like to have more of the pre-qualification artifacts for more of RTEMS than is currently there. But part of that is having help setting up the CI because you guys know a lot of how to do that, and it's much easier if you go, well, I did it this way, and this is what you need to do, and then it'll be up for us in a matter of days instead of maybe weeks for us to learn. One of the new things that has come out of the experimental physics community is they like to build their own images and then deploy it inside the development systems inside their own organization and have these under control. This is something fairly new, but it allows better configuration control, and you can do things like write RTEMS or tarballs or Debian packages, and then you have them on you can distribute them that way within your organization. So this is intended to help do that next step. You can define like your whole project is like, I'm using this BSP with this network stack and these add-on libraries, and it all just gets put together into whatever way you want to do it. So this is, it's pretty handy. It is in use, but it's not in widespread use. The big changes are finally, after 35 years, we're changing our workflow process. Right now, you send patches to the mailing list, and it often's a pain to set that up. Email clients mangle patches. We do reviews on the mailing list. Sometimes things get missed, and it's work on the developers because we end up having to download the patch from email and then manually committing it. We've noticed occasionally people have to ping patches to remind us that they're there, and it's just hard to do it. And I mean, this is an old way of doing it, but a lot of GNU projects still do it this way. GCC, for one, does it this way. But RTEMS, for at least 10 years, all of the .org infrastructure has been at Oregon State's open source lab, which is the same data center that kernel.org is on and a lot of other open source projects are on. So what we have done is every repository on get.rtems.org was converted to a GitLab project and assigned to a group. We are assigning code owners. The track tickets were imported as GitLab issues. This is our 4th bug tracking system over the history of the project. And every conversion, if you look back at an old bug, there's some reasonable chance that you might spot something that's weird from the database conversions, but they look pretty good. So this is going to be a user visible change. You can probably fix all this with Git at the command line. The URL for all the Git repositories is now different, and we finally went with the preferred naming of rename master to main. We did not merge accounts on track because some people come and go, and some of the accounts looked like spam. So everybody has got to create a new account on gitlab.rtems.org. Accounts are protected already by two-factor authentication using an authenticator app. The physical FIDO UB devices should be working in the next few weeks. Somebody asked about those. Basically, now you're going to do merge requests, and everybody can review. We're trying to get to the point where anyone with an account can review. Then there'll be certain roles. We're going to use it's an enterprise edition of GitLab because open source projects can get an enterprise edition. And we are trying to set up where every area of the source tree has a code owner who might be different, and then it could fall back onto the global approvers. So, and one of the things we're working on is you're not allowed to approve your own stuff, and hopefully 2 people from the same organization don't, sock puppet and start approving their own patches or anything. We're trying to figure out how to do that, but it's very difficult. So one of the things you can see, the top level organization here at the right, we have organized the repositories into categories, and and each one comes with its own CI pipeline and its own code owners. So at this point, we are still ironing out the details of mainly human factors of we're learning the new process and trying to fix it. There's stuff being merged and reviewed though already, and we encourage people to help review and be part of the process because it should be a lot easier. The other thing is that one of the other things that happened at the same time is we've been using Discord for a few years now. They have a level called a community server where you agree to do some things, like everybody who's got an account and chat says email verified. There's some explicit media content filtering, which I didn't know wasn't even an option, but apparently it was already enabled, so that's good. And there's some other things to help you do it. to do so there's a lot of channels, there's a lot of chat, and there's two, you can see down here at the bottom, there are, this is where you go to ask for questions about the GitLab, and these other three are automatic posts generated by GitLab. So if somebody comments or commits something, it goes into there. Let me say before I go on, one of the things that's really important with the GitLab CI change, we're going to slowly add things to it as things stabilize. But again, you guys all have great CI/CD systems and a lot of experience. We usually beg for help for code. We'd really like help once we start doing the CI to find out what you guys have done that works, so we don't have to learn on our own. And and again, like code examples, there's lots of ways to contribute. So Laurent presented earlier and on Deos and Deos RTEMS. So a number of people here are aware of the FACE technical standard in the FACE consortium. It came out of Army and Navy aviation, but I know it has been pitched over the years to the various space community. Depending on the profile, the FACE has 4 profiles, and 3 of those require ARINC 653 and the ability to run either Apex ARINC 653 application in a partition or POSIX application in a partition. So we partnered with DDCI, and you get their native ARINC 653 services, and then because of FACE, RTEMS brings in the POSIX capabilities with support for using Apex sampling queues, sampling the other one, queued, the 2 types of ports and shared memory to communicate, and there's some other special integrations with the 653 environment, so you're a full partner. We have been approved on, we've got 3 of the 4 POSIX profiles, and we are 1 POSIX method away from supporting the largest one. We have been through FACE conformance with this product, which means we met all the requirements. We have done it to the edition 3.1 for 3 architectures, ARM, PowerPC, and 32-bit x86. The 64-bit ARM should be available now, and we will eventually get the certificate of that. One of the things from an OER services standpoint, you all know that we're happy to do anything we can to help you with RTEMS. We'll do training, support, custom development, answer questions. We are doing the same things for the FACE technical standard because, obviously, if it's based on POSIX and modular open systems architecture and modeling, it's all the same things we've been helping people with through RTEMS for years. This just puts another filter on the same kind of services. The only thing that's particularly different, because we do FACE training and RTEMS training, we also are a FACE verification authority. So if you're interested in, maybe you've got something that needs to conform to the FACE standard, we actually can do the verification work and get you through the conformance process. So then, so that's what we've been busy doing. But from the other slides, other than that, we're completely on the .org. One of the things, and Matthias talked about I usually mention something about the ESA qualification work. I didn't this year because he was here. I will say that there's a handful of us from the .org open source, pure open source side point. We took the view that we want the pre-qualification stuff merged into the project. It has to be completely using open tools, and we have the serious challenge facing, in some ways, every one of us. How can first, we want the open source projects to have those kind of quality artifacts with them and be able to qualify them. At the same time, how do you do that with an open source project and not crush it or require it to have expensive tools that obviously the project can't have? And a corollary to that is, how many students or people doing a master's thesis actually know how to write requirements or do any of this? So, we have a serious problem teaching people how to do this kind of development, and that's one of our biggest worries, is that we're going to end up having to, ultimately we need to find colleges, people doing software engineering classes or other cases where they could actually use at least RTEMS, since you've got the artifacts and the technical data input, so they can become familiar doing something real. But we have lots of opportunity for help. The GitLab CI switchover, we have not turned off everything that was there before. That's the process that's coming up in the next couple of weeks. Our wiki is going to be dumped into static pages, and then we will reuse some of the content. But we are really hoping that this makes it easier for people to contribute in various ways. It certainly opens up ways like the CI, because we have a few things like it was mentioned. I mean, we can do coverage on embedded hardware or simulators now, and I mean, we heard actually it's GCC 15 apparently where the MCDC work is going to show up. That means that normally, using normal RTEMS tooling, you will actually be able to generate MCDC reports. So, I mean, there's a lot of things where the ESA pre-qualification and other work has kind of synergy has done that. So that's basically kind of what has quietly been going on. And I've noticed a trend over the past few years. There's always code improvements or things added, but we have been working a lot on processes and deployments to help people actually better manage things on their side. So so it's an interesting change in focus. There's better ecosystem tooling. So that's just trying to help everybody. And again, RTEMS only exists after this many years because you are using it. And please tell us if you have trouble, please don't be ashamed to say it. If you want a new feature, don't be ashamed to ask. It could already be there. It could be that I've got a couple of pet things for system logging and monitoring that no one has ever asked how to get information that I expect people to ask, but I don't know how somebody would want it in a real system. And so we're happy to take suggestions. It's open completely. Even if the discussions are embarrassing, they still happen in the open. So, and I guess that's me from finding out that it's over and we can go to find out where this is going to be next year. Thank you. Okay.
I don't see any questions online. Any questions?
Actually, it's not a question, but just a comment on what you mentioned about the pre-qualification kit and also that we could use this to teach new people. I find it a wonderful idea, so
It's what?
I support it. The comment you mentioned about merging the pre-qualification kit in RTEMS, and that could be used also for teaching new people about these processes.
Right, and it's a completely different type of person. I mean, we all have written requirements probably, but that doesn't mean that we don't need more people who can do that, because it's really hard. I'm only convinced that you write requirements on a project, and eventually at the end, you'll realize that you didn't write good requirements and that you'll never write requirements like that the next project, but you do it anyway, so.
Yeah, it's an art.
It is an art.
Any other questions?
And I shouldn't, you've got some really cool RTEMS stuff going on, and the RISC-V support in RTEMS is in great shape. It went from like nothing to SMP and every core model supported in less than a year. It just popped up like instantly. It's not one of those where it even made the beg people to work on it list. So.
Thank you.
No problem.